solve the system of equations. Then graph the equations in the system. So to get us started, let's begin by identifying what equations are we working with. Looking at equation 1, we realize that we're working with a circle centered at the origin with a radius of 10. And equation 2 is a line. And if we convert this to its slope-intercept form, we can see that this is equivalent to y is equal to minus x minus 2. Now, to solve the system of equations, we want to first solve either equation 1 or 2 for x or y, and then substitute that into the other equation. So considering that we already identified or converted equation 2 to the slope-intercept form, y is equal to negative x minus 2, let's substitute equation 2 into equation 1. So in other words, what we are going to do is replace the y in the circle with the minus x minus 2 of the line. So now we are left with an equation in terms of the single variable x, and we're ready to simplify. So the x squared remains as it is, but in order to solve this equation, we need to expand this binomial product. So we have minus x minus 2 times minus x minus 2, and applying the FOIL method, we can simplify this to x squared plus x squared plus 4x plus 4 is equal to 100. And combining up those like terms on the left-hand side, we have 2x squared plus 4x plus 4 is equal to 100. Now, of course, we know that in order to solve a quadratic equation, we must set this equation equal to 0. So we are going to subtract this 100 on the right-hand side from both sides to leave us with 2x squared plus 4x minus 96 is equal to 0. Now notice, all of the terms on the left-hand side have a greatest common factor of 2. So pulling this out and dividing both sides by 2, we are left with the simplified quadratic equation, x squared plus 2x minus 48 is equal to 0, which is just a little easier to solve. So factoring this, we are left with the binomial product, x plus 8 multiplied by x minus 6 is equal to 0. And applying that zero factor property, we can solve each binomial separately to find the x-coordinates. So looking at case number 1, if we subtract 8 from both sides, we are left with the first x value of x equals negative 8. And in case number 2, if we add 6 to both sides of the equation, we're left with the second x value, x equals 6. So now that we have these x values, for each x value, we can find the corresponding y by substituting it into either equation. So I'm going to use the equation of the line, but feel free to use the equation of the circle as well. So when x is equal to negative 8, when we substitute this into the line, we find a corresponding y of 6. Making our first solution point the ordered pair negative 8, 6. And when x is equal to 6, when we substitute this into the equation of the line, we find a corresponding y of negative 8. Making our second solution point the ordered pair 6, negative 8. So these two ordered pairs together form the solution set for the system of equations, and as we will shortly see, are going to be the points where the graphs of these two equations intersect. So let's go ahead now and take a look at their graphs. We are now ready to graph the equations in the system. Now, to begin, let's recall that we just found that these two equations intersect at the ordered pairs negative 8, 6, and 6, negative 8. And to guarantee that we are graphing the most accurate sketches possible, let's go ahead now and find the x and y intercepts for both equations in this system. So starting with equation 1, the equation of the circle centered at the origin with a radius of 10, we can use the center point and radial length to find these x and y intercepts. So thinking about the x-intercepts and beginning at the origin, if we move 10 units to the left and right, we can see that we have x-intercepts at the ordered pairs, -10, 0, and +10, 0. Very similarly, from the center point, moving vertically along the y-axis, we can see that we have y-intercepts at the ordered pairs, 0, -10, and 0, +10. Now, connecting these x and y intercepts with a smooth curve, we can see the graph for the equation of the circle, x squared plus y squared equals 100. Now let's do the same thing for the equation of the line, x plus y equals -2. Or using our slope-intercept form, y is equal to -x minus 2. So for the x-intercept, if we let y equals 0 and solve for x, we see that we have x equals -2, or the ordered pair, -2, 0. And for the y-intercept, if we let x equal 0 and solve for y, we see we have y is equal to -2, or the ordered pair, 0, -2. And connecting these x and y intercepts with a straight line, we see the graph for the linear equation, x plus y equals -2. So there you have it. Here is the graph of the equations in the system.